Hi everyone, in this video we're going to talk about string manipulation with glue and stringr. So now we're getting into the type of course, the part of the course where we know how to manipulate data frames with dplyr and do various things with dplyr. Now we're going to talk about the special types. So what if we don't have numbers? We're going to talk about the special types of objects or data types in R. Strings, we're going to focus on strings this week, and then we're going to look at other data types next week. But strings are harder to work with than numbers, and so we need special functions to work with them. Okay, we're going to talk about two packages, glue and stringr. Okay, so we'll talk about, we'll give it a little intro to what we're going to talk about. Then we will talk about string injection with glue and string manipulation with stringr. Okay, there's lots of things that are going on. The stringr package is pretty big. Glue is smaller and has a more focused goal, but we'll talk about both. Okay, sorry, and then we'll talk about regexes, and we'll have a data cleaning example. Regexes will be a separate video, but we'll get there. So glue and stringr are both tidyverse packages for string injection and manipulation. I guess I should be more clear. Glue is not actually loaded when you load the tidyverse. You have to load it yourself, but stringr or stringr is loaded with the tidyverse. So we'll get there. String manipulation is essential for data science because, well, you're going to work with a lot of strings. There's a lot of text analysis. Almost everything is going to be a string, have a string, will maybe be loaded into R as a string, and we don't want it to be a string anymore. Strings come up a lot, and we're going to work with them. Okay, and so we're going to pay special attention to what are called regular expressions. They're strings that signify special patterns of characters in other strings. We'll get there, but many of the stringr functions rely on regexes. Okay, and so we will eventually get there, and they are odd if you haven't seen them before, but hopefully will be interesting. They're kind of like a puzzle. And so if you like puzzles, I think this should be fun. So anyway, here's the stringr cheat sheet. Okay, again, as in all of my videos. But let's first talk about glue. Okay, so glue, smaller package, more refined goal, is string injection. So glue's main function is the function glue, so package glue and function glue, creates strings and can inject R objects into strings. So it has two arguments that we're interested in. The strings that you want to do stuff with or to or create, and that's the ... operator. And then, of course, how to separate the elements, and that's the SEP or SEP argument, not operator, I'm sorry. And so I can start with just something like this. Okay, hello, my name is, and then I put my name, and it prints something out. Now that's not very exciting because I could do that with just, I don't know, the C function. I could create a vector, although this is not quite, it's a special type of vector. Okay, but I could do this easily without glue, so why do we need to use glue? Or why is it helpful? It's helpful because you can inject code into the string. So if I define here first name, and I put my first name, last name, I put my last name, and I use glue, and I say, hello, my name is, and then in curly braces, so inside the two sets of curly braces, I put the two objects that I've defined in R. So think I've run that first line of code where I define first name and last name, and then I run the glue code, and lo and behold, it injects those objects into the string. And that can be helpful for us. So, sorry, here we go. Okay, so here I create a longer function, or longer code that shows you a bit more nuanced stuff. I put my name, I put my age, okay, which I'm older now, unfortunately, a year older, and then I put my anniversary, okay, which is true when I got married. And so my name is name, my age next year is age +1, and my anniversary is, and then I do some formatting of the year. And so my name is Grant, my age next year is, well, it would be 31 now, and my anniversary is Saturday, July 14th, 2018. Okay? And so where you could use this is if you're creating something like a mass email to go out to people. You're trying to like batch emails on some list and you want to personalize the greeting, so on and so forth. Now, any like Outlook has the ability to do that, Gmail, so on and so forth. But what it's doing under the hood is something like this. Okay. I'll show you an example here, I think, after I talk about some glue variants of how I used glue to my advantage in a project that I was working on. So glue has other functions that perform more specific tasks. So there's glue data, and glue data works with pipes and exposes left-hand side names. And so that's like, we don't need to worry too much about that. Glue data, glue collapse, glue call, etc. So there's lots of glue variants that you might need to use in certain circumstances. Okay, so what about glue in the wild? And so where I used glue is I was doing some work with, not really work, we were just exploring this idea that somebody had with a few colleagues in the math department and some students to see if we could start up a little project. And so the project was, we were trying to predict what affects a kick in the NFL. But the full project is like you're trying a field goal and what could possibly affect that field goal. Clearly the length of the field goal, but all kinds of things. That's not really important. What's important is that we also wanted to consider the weather. And unfortunately, we didn't have the weather in our data set. So we had we had the game it was in, we had the quarter, we had almost the exact time, so on and so forth. But we didn't have the weather. Lots of variables, lots of data, no weather. But we wanted to include the weather. And so what my job was, as the person who I guess does data science the most, was to find, see if I can find, okay, yes. So find weather on the games. And so we found this website that is, it's not the most fancy website, but what it does have is, a lot of weather stuff. And so if I can remember, okay, it has weather archives. It hasn't been active since 2021, but actually this was, so maybe not good for if we want to do weather now, but we were working in 2021, so it was wonderful for us. And so if we look here, if you look at every single page, so we were trying to find a lot of games because there are a lot of kicks, and so it has all of the games. Okay, and it has specifically, if we clicked on this, it has details of, the temperature, the humidity, lots of good weather information here. And so the question was, how do I scrape all of this data? So we'll talk about later on web scraping. So that's a separate issue. How do I get this down into R? We'll learn about that in a second, or in a separate video. But here, what I needed to do was how do I grab all of these games? And so something important in web scraping is looking at the structure of the URL. And so if we look at the structure here of the website, it was very helpful in how they structure the website. Each one is a separate page. It's not in some dynamic page together. Again, website things that we don't really need to worry about too much. But I did for this project. Okay, and so you see it has the regular game, and then it has, so it is a game. It's in 2021, week 6, and then it's Seahawks at Steelers. And so I had all that information in a separate data set. So I had who was playing, I had what week it was, I had what year it was, so on and so forth. But I needed to format, so that existed in my data, but I needed to format and get a URL so that I could then go to the URL and scrape it without me having to personally do this for every single kick. And so glue was helpful because I could take what week it, so I could structure the URL like this. I know it's always going to have like dash at dash, but I know the last name, so like the team name of the person, the away team was first, the home team was second. I know it's week dash, and then I put the actual week, so on and so forth. And so I could inject that information, the year, the week, the teams, and then easily scrape, 500 websites, 600 websites in the matter of seconds. Okay, hopefully that makes sense. So that's one place where I used glue. Hopefully that made sense, and you'd see why glue might be important. Now, to stringr, the more extensive packet. So stringr is much more extensive, and it does more stuff for string manipulation. Okay, stringr functions always, as usual, you'll see, or what we've seen so far in the tidyverse, all of the functions have a similar naming structure, and so the stringr functions do as well. They all start with str underscore. Okay. Now, where does stringr come from? Stringr is a wrapper. So stringr functions are wrappers of a fast C++ library that do this thing called stringr or string-i. Okay. You can, in R, interact with string E sort of natively. There is a string E package that interacts with those C++ functions more directly, but they are much more complicated, and so we want to use these wrappers. And so when I mention a wrapper, it's just a function which really does some stuff to the inputs and then feeds it to another function. So really I'm using the stringy functions, but I'm using the nice wrapper of stringr. Okay. The functions can be grouped into 6 categories, and so we'll go over each category quickly. Detecting, lengthening, joining / splitting, subsetting, mutating, and then sorting or ordering. Okay, so we're going to use this vector. There is a vector that the tidyverse provides for examples in stringr, and it's fruit. Okay, so fruit is an example of things that are characters. Okay, so here's fruit. There are 80 fruits in the vector. And so the glimpse function is not part of stringr, but it is helpful to view what, to get a glimpse of what a structure is. Yeah. And so detecting, the main function for detecting is str detect. Okay. Can I detect apple? And so it gives me a true or a false, whether it detects apple or not. And so if you look, of course, it detects apple as the first element. But if you look way down in the what looks to be the 62nd element of this vector, there is another true. Okay, and you can think for a few seconds what it might also detect. And the answer is a pineapple. Okay, so pineapple contains apple. So it doesn't have to be an exact match of the entire character. It can match part of it. Yeah? Okay, so detect which elements of the vector contain berry. There's a lot of berries in fruits, and so it gets us a fair number of elements. So notice we didn't get trues or falses back. We got the actual elements. This can be helpful if you want to subset. So if I wanted to subset and find the actual names of things that have berry in them, I could use this to find the indices and then use my knowledge of subsetting to subset. Okay. str count. Counts how many A's are in, so in this case, counts how many A's are in each one. Okay, that could be helpful in a myriad of different places. So str count. Now, subsetting with str sub. Okay, and so str sub, and then I feed it 2 and 4. So you can think about for a second what that might do, what that might look like. And it looks like this. Okay, and so if you were in class, I'd say, well, what does str sub do? And we'd talk through it. But here, you don't have to sit through the discussion. It of course, takes the second to the fourth element of the fruit name. Okay, so apple is 5 letters, cuts off the A and cuts off the E, and you have the second through the fourth, which is PPL, and so on and so forth. Okay, str sub, so you can give it, well, what looks like, 2 separate numbers, so 2 arguments, or you could give it a -2, and it's going to give you the last 2. So for apple, it took away APP and just left LE. Okay, so -2 gives you the last 2. There was str sub, now there's str subset. Okay, and so it is, well, just going to subset the data set to only give you, well, here, apple and pineapple. So this does the str which and then does the subsetting for you. Okay, so it sort of skips a step and is more powerful. Okay, str extract. Now here are the functions that I use the most in working with strings, is you might want to extract things from each element of a vector or data frame or whatever. Okay, and so APP, it takes APP from apple and APP from pineapple as well. Okay, lengthening. So I first 5 elements of the fruit vector: apple, apricot, avocado, banana, bell pepper. Okay, and str length will give you the length, of course, of the string. Great. Pad does this. Okay, so I might want, it may be the case that I want all elements or all characters to be of length 11 for some reason. Okay, and so I can do that with str pad. And so 11, and then there's an L next to it, and if you remember, the L next to it makes it an integer. So if it was just 11, it would be a numeric, it would be a double, but L makes it an integer. It would probably work with just 11, but we wanted to be specific here. And so the padding happens by default to the left, but you could make it happen to the right. Okay, left or right, and with whatever symbol you want. So if you want not just a white space, you can change that as well. Okay, now there's also truncate. Okay, and so you might want everything to be short, and so 6 or less. And so if it's longer than 6, it's going to cut it off to the 3 and then ... Yeah, okay. And then there's str trim, and so I take my padded stuff. So I have the 5 elements. I pad them to make sure everything is of length 11, and then trim is the the opposite. It trims white space or trims extra space. This is advantageous for things like when you are entering in a password or a username or something to a website to sign in, right? So sometimes you might hit the space key before or after you start. There might be some weird white space going on there before you even know it, or after, so on and so forth. And so if any sort of website is worth its weight, it probably should include some str trim somewhere so that it can ignore that extra white space. Okay, some websites do, some websites don't. Okay, now under mutating, str replace. So I'm going to take P and I'm going to replace it with an underscore. And so what does that look like? Well, it looks like this. Okay. str replace replaces the first P that it sees with an underscore and leaves everything else alone. So you see the second P in apple is still there. The second and third P in bell pepper is still there. It's just the first one. There is str replace, and then there's str replace all. It's going to replace all of them. Okay. There's also str to upper and str to title and also str to lower. Okay. Those str to upper, to title, to lower are helpful if you want to change the names, tidy up the names of your data set. So sometimes when you get a data set, the names are ugly. There's like spaces in them. They're all uppercase. They're weirdly cased. Okay? And so you can use these stringr functions to help you fix the names. Okay? There are also specialized functions in other packages that do all the fixing of the names that you'll see me use or have already seen me used. Okay, seen me use. So now on to joining and splitting, strc. Okay. I used to have a vector of length 5. Now I have a vector of length 1, and it pushed all those names together and put a space. Okay. So here, strc, and then I can put multiple things together. Okay, I'm using the pipe operator, and I'm putting the fruit vector not in the first element of strc, but actually in the second element. So that's why there's a dot there that's sort of weirdly placed. If you want to put whatever's on the left-hand side of the pipe into not the first element, maybe the second element or the second argument, third argument, fourth argument, whatever, of the function to the right, you do that with a dot. Okay? And so here's an example where I might have like a terrible naming scheme, and I want to sort of put something on the front that will make it a little better. I can do that here with something like that. Okay, so putting things together. This is like a base R has something like this called paste. Okay, paste. You'll see that if you search, you'll see a lot of different functions that do this in base R. And they're called, well, two of them are paste and paste 0. So anyway, that's strc. str split is the opposite of strc. Okay, so I put them all together, and then I split them apart. Okay, which almost works, but bell pepper already had a space, and so it's now two separate things. Okay, but it splits based on what you want it to split by. So I put a space there, and then I split by space. Okay, now we're getting there to the end. So sorting and ordering. str sort. Okay, it's going to sort by alphabetical order. Order gives you the indices of the order. And then that is the end of stringr. So one final note that I touched on a little bit before is that there are a lot of functions in base R that will do this for you. Okay, many of them are. So there was, I said, paste and paste 0. Those are not so bad. There are lots of others, and so there are functions that follow string manipulation that happens in the command line, gsub, and the like. I do not want you to use gsub, so I want you to use stringr function. So when I ask you to manipulate strings, I want you to use stringr. Okay. Anyway, so that's my last note. Okay, and so hopefully that video was helpful and also not too long.